Good morning, everyone, again. I'm terribly sorry I cannot be there in person, and I hope this doesn't interrupt the whole tutorial too much. So I'm assuming that for this tutorial, I'm not assuming anything, basically. We're going to start from the very beginning. I have a few leaflet calls that we're going to do just to show you how verbose things can get very quickly. And then we're going to jump to map view. We're going to take a slow pace and so I just continue, I guess, unless somebody tells me to stop. So we're going to take a slow pace, and in the morning it's going. Is there something wrong?
Yeah, sorry, we just have to turn one of the audio sources off.
I guess it's better.
I think this is better.
Yeah.
Okay. Okay.
Sounded too distorted.
Okay. Okay, you can continue.
Okay. So let me start here again. In the morning session, we're just going to have some basic functionality. Like I'm going to show you the breadth of the functionality of MapView, what you can use it for, how you can customize it to your needs via global options and all that. And in the afternoon, we're going to have, there's a different script here. We're going to look at how MapView scales if your data becomes large, because that's one of the biggest issues that the leaflet package has. It's nice for smallish data sets, but it really trips over itself when it comes to larger data sets. So if everyone's okay with it, I'm just going to start right here. All right. I'm using our version 4.0.2, so the latest stable release as far as I know. And if I call library map view on my computer, you see that I get a little notification down here that says GDAL version is larger than 3.1.0. So I'm setting the map view options FGB to true. That means that I have access to some flat GeoBuff rendering engine right now, but I can easily switch that off by just setting map view options FGB to false. Now, I'm sure that not all of the people in the room will have the same setup as I have, but that's just the way things go. If there are any questions, and if you want me to show you how things look like without the FGB option, then let me know and I will just repeat the code with the option set to false.
I see there is a question actually on Zoom.
Okay. Let me just
Q&A and the taskbar.
Yes. Okay, I think you have a high resolution display, and I've not seen that error before. I'm sorry. So that is something new to me. Have you tried opening or like setting the viewer suppress option to true? Because that might just be an issue in case you're working in our studio, but I'm really not sure about this question. If that error persists for you, please open a issue on GitHub and we can take it from there. Sorry, that's all I can say at the moment. All right. Loading all the packages that we need, leafem, leafgl, and leaflet. And then for the...
Tim, sorry to interrupt, but a question from the audience here. Can you make the font size a little bit bigger?
Oh, yes, sure. Where is it? Global options, appearance. let's just go here and do it like this. Is this better or even bigger?
Okay. The question if you can turn it to white.
Yes, of course. Classic. And where is it? Let's use this one. Let's see. Is that better?
Perfect.
Cool. Then, all right. There's three spatial data packages that we're going to use in this tutorial. SF, and that tells me that I have GDAL 3.1.0 installed, so that's why mapview figures out I can use the FGB option, because FGB as a file format or as a driver was only introduced in GDAL 3.1. But I personally find it so much nicer to work with this FGB data that I decided to automatically switch to using it whenever it's available. And there's the stars package. I think Etza told you all about this on Monday, if I remember correctly, and the good old raster package. And then we're also going to use some color definitions from the R color brewer package. So as I said, I'm going to start off by showcasing leaflet a little bit, just to make the point what you can do and how verbose it gets pretty quickly. So if you do a very basic call, just leaflet add tiles, you will get a interactive world map that you can zoom in and out and zoom around. Add tiles uses the standard open street map tiles, and let me see if I can find, we must be somewhere here, Wageningen, I don't know. And that's pretty much all you get there. If you can set the view, and I set that to Wageningen now, but then you have to call another line of code, right? We can also change base maps in leaflet. So if I define some base maps from the leaflet providers package, then these will be used as my base maps if I set them in a function call called add provider tiles. So I use the first one, and you need to give it groups if you want to be able to switch between those two. And these groups you will then use in the add layers control to enable the switching between those. So what you get here is, first of all, the CatoDB dark matter. So I can just zoom out, and it's a very dark representation of everything that's going on. And now I have this little add layers control up here where I can switch between the light version of that same map type, basically. I show you those two because those are two of the default maps that mapview ships with, but we'll see that later on. If you want to add data, leaflet provides a handful of functions to add either point data or markers or polygon data or line data. So here we're going to use the same maps basically, and we're going to add some polygons from a data set called Franconia that ships with the mapview package. If you're active on Twitter, you might have seen me using that most of the time for stuff I post there. And we're also using, we're adding some lines here in the next call from a dataset called ATL Storms 2005 that used to be a mapview dataset, but now is in leaflet. And then we're going to add a layers control again. And you already see that we are now up to 20 lines of code. I mean, I like the styling of the code this way, that I put successive lines underneath. But you could put this in one line, but then you'd have to scroll all the way to the right, basically from Wageningen all the way to Arnhem, I guess, in reality. So if we execute this, we see that we get the lines data from the ATL storms. These are basically just storm tracks from hurricanes in 2005 or from some storms in 2005. And we get the Franconia data, which is basically just the administrative boundaries of a certain region in Germany. And that is included because here you see the city called Nuremberg, and that's where I currently am because I lived there. So you already know, you always know where to find me when you use the Franconia data set. And what we did here as well is basically say, okay, I want to have overlay groups that I can control with my layers control and base groups. So the base groups are the same as before, the light one and the dark one. But now I also have overlay groups where I use the group definition of my add polygons layer and my add polylines layer. So I can click those on and off by just selecting or deselecting those. Okay. And this is like the minimum setup that I would call usable for investigating your spatial data in an interactive manner. But now you don't have any information about what's behind these geometries. So you're basically just seeing the geometries, but there's no way of knowing the attributes that come with these geometries, right? For that, you would need to define pop-ups or labels, and that's what we do here. So you can just go pop-up and refer to one of the attribute names in that dataset Franconia with the tilde. And for the label, I use another one. And I do only a label for the storms data. And I change the color for the storms data here. So you see it's quite modifiable, the whole thing, or customizable. So whenever you hover over one of these lines here, you now get the name of the storm. And if we zoom into Franconia, you get as a label that is just always following your mouse, the NUTS code, which is a European code of these areas. And if you click on those, you get a pop-up with just the district that these regions belong to. So you have Oberfranken, Mittelfranken, and Unterfranken. So that's how Franconia is divided into 3 groups, basically. But you see that now we have quite a verbose call. And if you quickly want to visualize your data, I think that's a no-go, because in the time you write this code, you can easily just open up QGIS and drag and drop your stuff in there, and that's quicker and easier. So that's where mapview comes in. As I said earlier, I call it a data-driven API for leaflet because it's designed to abstract away many of these functionalities that we've seen here. And it's data-driven because it knows which of these add polylines, add polygons, or add circle markers to call, depending on the data set that you provide. But let's start basic. If you simply call mapview without any arguments, you get a map like this that depicts the Elisabethkirche in Marburg, because what you see here is the Department of Geography of the University of Marburg, and this one also, and that used to be my office just here. So that's why I decided if you call mapview just like this, you will get will be automatically zoomed to where mapview was created, basically. As the default map, you get the light map, because a light map background usually facilitates seeing patterns in colors best. It might not look as fancy as the dark background, but you can switch to the dark background. You also get OpenStreetMap representation of it, and you also get a satellite image view, so you can zoom in quite far here and see all the details there. At some stage, that will just go away. Most of these tile providers have tiles available up to a zoom of 18. Some of them up to a zoom of 19. I think that's, for example, the CartoDB. Maybe the OpenStreetMap. Yes, I don't think the OpenTopomap. The OpenTopomap also apparently only has up to zoom 17. But the OpenTopomap is quite nice depending on what kind of work you do, because you get a nice topographic representation of the Earth. So it highlights topographical features, basically. What you see up here is a strip that basically always follows your mouse, so it tells you where you are on that map. And that's pretty much all you get for free. Plus down here you get a scale bar, but you have to be careful, and that will change in the future. That scale bar is only representative for the center of the map. So it's not 100 kilometers down here where it's located. It's 100 kilometers right in the center of your map. And that makes a lot of sense. If you zoom out a little further, you see how that changes quite drastically whenever you approach the poles, because the Mercator projection that Leaflet uses is just highly distorted towards the poles, right? But that's a visual aid for you to say, okay, right now in here, that's about 3,000 kilometers. All right, if you want to add some data to it, you just supply it as the first argument to mapview. So mapview Franconia will automatically decide, okay, we are, that's a polygon data set, so I need to use add polygons. Then you will get, again, the strip with the mouse coordinates. You get all your base maps here. You can switch the layer on and off, and you will get a legend for it, which debatably does or does not make sense if it's just a single color. But if you have more of those, you will at least see what you have. And what you also get is a little button on the bottom right that automatically zooms you back to that extent of that layer. So if you add more layers, you will get more of these buttons down here that can get a bit distracting, especially if you have big legends, but we'll see that later on. You can also write this to an object. Nothing will happen in the browser, but if you then call that object, which I just named M, then you will get the representation in the viewer. And same thing, and that's, I guess, the most important part of the whole thing. For each of these geometries, in this case, points, you can, by clicking on it, query their attributes. So all the attributes that are behind the geometry for this particular point, you will get when you click on it. Now, if you don't have the flat GeoBuff rendering available, these pop-ups will not look as colorful at the moment for you, I guess, but rather plain white, because there's some issues with the CSS that didn't get resolved in the last CRAN or CRAN update. But I'm working on fixing those ASAP. So that much for vector data. We can also use raster data with it. And in this case, I'm using the stars library to read a TIFF file that comes with the stars package. And I think Etza told you about this on Monday. That is basically an array-based representation of satellite data. You have a XY dimension of this data set of roughly 350 by 350 pixels, and you have 6 bands for this. And you get a nice summary of the data values that you find in there. So all of these 6 bands carry information that is numeric and lies between 1 and 255. There's also some information about the coordinate reference system. And now, if you call this, at the moment, for stars, we only support 1 layer at a time. So you cannot call more layers than 1 at a time, but that will change soon, so that we can also just do band C 1, 2, 3, and you will get 3 layers in your map view. So if I do this, this is what I get. You get some standard coloring that is based on the Inferno color ramp that comes with either the Viridis light package, or this one actually uses now the HCL colors function from base R that was introduced in R 3.6.1, I think. And that basically just renders band 1 of your stars data, and it's the same as with the vector data. You can switch on and off. You can zoom to it by just clicking on that button down here. You get the legend. If you switch it on and off, the legend will disappear, so it's always tied to the layer. And this one for stars objects now uses a very newly introduced rendering engine in MapView that is called, what is it called? Raster layer for leaflet, I think is the JavaScript library's name. That has the advantage that it does resampling of the data to larger pixels as you zoom out and to smaller pixels as you zoom in. So basically, it's trying to be smart in the sense that when you are zoomed out quite far, you can't see all the 350 by 350 pixels anyway, because your screen resolution is much lower. So that might actually be one of the reasons for that error message in the chat, but I need to investigate. So this is really nice because that allows you to actually view larger data sets and still get an acceptable performance. For this kind of data, we can do this with the next 2 lines and see the differences. If we convert the first band of this X1 stars object to a raster object, we then have the data in a raster representation. So it's a raster layer, so that comes from package raster. Same dimensions, about 120,000 pixels. You get the resolution, and you also have the information about the projection. If we visualize that, we realize that this takes a bit longer. And that is because it needs to read all the data at once, and it does not do any resampling on the fly. So if you zoom in here, nothing changes really. Like the pixels always stay the same. And that is just overhead that you don't need to have. But the advantage of using the raster representation, at least at the moment with MapView, is that you will get on mouse over. So if you hover over your with your mouse over the layer, you will see a little window pop up here that tells you the value of the pixel underneath your mouse. So here the pixel value is 112, here it is 101. If we go here, it's lower, so just 60. Here it's a bit higher, I assume 124. And then the highest values are somewhere here, where you're getting up to 250. Now, given that these are actually integer values, and what you see here is floating point values, that is a result of the reprojection that MapView does for you on the fly, because the WebMarcator representation of leaflet means that we, in order to see our layers, we need to reproject them to that projection, otherwise they won't be visible on the screen. And MapView does that for you. And whenever you reproject the raster data, you need to come up with a strategy of how to interpolate the pixel values that are being shifted. By default, the raster uses, and MapView in that case too, uses a bilinear interpolation. And that for integer values means that you end up with floating point values, and that's what you see here. But what you can do is in MapView set, if you call MapView RST, you can set the method argument to NGB, which means nearest neighbor. And if you do that, I hope that works, then you get the nearest neighbor interpolation. So your integers actually stay integers, right? And if you want to get rid of these trailing zeros here, you can, I think, have a argument called query.digits. If I set that to 0, then those digits should be gone. Yes. So then you get the proper nearest neighbor interpolation, and that layer up here, or that window up here, will only show you the integer values that are underneath your pixels as you scroll over them. Now, given that it's a bit hard, I mean, MapView, as I said, is trying to be smart. Whenever you feed it a categorical raster layer that is defined as a factor, as they call it in R, then MapView will use the nearest neighbor interpolation by default. But given that these are integer values, we don't know what they represent. They could represent land use cover classes, or they could just represent gray values, as in this case. And for that, it then doesn't make sense for MapView to try to be smart and do something that is not desired. So we just stick with the default, and the default in that case is bilinear interpolation. All right, the rest is the same. You get the same controls, the same base maps, and that might just help you figure out to work with your own data, whether it's correctly aligned or it's not. There might just be misrepresentations of your land use classes or whatever. So that should really help you to figure out what's going on. All right, so much for just a basic overview of vector data, how MapView deals with it, and raster data, how MapView deals with it. Now, let me go into a bit more. And by the way, don't worry about these warnings. They come from the raster package, and they have to do with the fact that there has been a lot of change in downstream dependencies, GDAL, GEOS, and proj, regarding projections and everything. And this is just being shown here. I think that's either from the raster package or from the RGDAL package that raster uses under the hood. These will go away in due time as development of these packages continues. And for MapView, these will go away at some stage anyway, because as I said this morning, I'm planning to restructure MapView internally in such a way that it uses stars under the hood rather than raster under the hood. Right. Now for the internal structure of the MapView objects that you get. MapView that is a design decision that I made early on, and that is just to be as honest as I can, as a decision that I partly regret, but I've made this decision simply because I didn't know any better at the time. It was the first time for me to deal with class representations in R, and you might know that there's S3 classes and S4 classes, and more recently there's also a R6 class. And for mapview, at the time when I started creating it, I decided to use S4 because the raster package used S4 or still uses S4. And that was the only one I understood. I only understood how the S3 class realm works by having a very deep look into SF and following along SF development by Etzer. So in retrospect, it might have been better to use S3, but we're stuck with S4 now, and that's not going to change anytime soon. Just as a bit of background, because that might explain some things that you see when using mapview. So that S4 class, as it's defined, is called mapview. Comes from package mapview and will always have 2 slots. So your mapview object, if you assign the mapview call to an object called M in this case, the structure is you get 2 slots. The first one is called add object, and that is basically the plane geometry representation of whatever you see on your map. And then there's the add map slot, and that is basically the leaflet map that mapview creates for you. Okay, so you can just as well call M, no, not like this, just M to get the visual representation of your data, or M add map, then you're explicitly calling only the leaflet part of it, but the result for you is the same in the browser or in the viewer. Okay, if you call M add object, then you get the SFC object as a list. That has to be a list because you can have more objects than one on one map. But then that gives you the SF type representation of what you see on your map, but only the geometries. So the attributes are not there because they're already queryable here with the pop-ups. That class will always be then a SFC class. So that's what basically the geometry column of a SF object will always be of class SFC. So SF column object, what it's called. The class of the map is, I said, a leaflet object, and the class of M itself is a mapview object of class mapview. So just as a very basic background for you to understand that there is some discrepancies between the class representations because leaflet and SF are both S3 classes and not S4 classes, but they are in mapview wrapped in one S4 class. The next I want to show you is the methods that we have currently defined in the package. So X is always the object that you want to visualize. In this case, for example, franconia. So franconia is a SF object, so that calls the method for SF. So X is always your object that you put when you call mapview. You can do for a bbox, that's a SF bbox class. We have methods for character that basically refers to file paths, or in the future that will also allow us to stream URL based data, so somewhere hosted on the cloud, to directly stream into your map. We can use MapView for visualizing data frames. I can maybe quickly show you this like this. Just use the iris data set, but for that I need some, okay, so we can do map view iris, but then we have to explicitly call xcall and use, for example, this one. So map that to the X and Y call is then this one, map this one to Y. And I now hope this works. Yes, it does. So what you get is a mock-up scatter plot on a leaflet background without the maps, basically. But you can still do your querying with the pop-ups just as you can on the map background, right? So that's basically maybe more of a toy method that we have here, but it's there in case you want it. We have methods for lists. Those expect spatial data. We have some sort of other methods that are quite handy to have. So nothing happens if you do map view null. That can happen in a programmatic setting when your previous computation just returns null. And you call map view, you don't get an error, you just don't get anything basically. You can view numeric vectors just as we did here now, basically. So you can do point and line plots there. We can do, as I said, raster data. There's a package called satellite that is also supported. Then we have all the SF and all the SP data classes that are available. And we have stars and stars proxy support and even XY support. So the very basic SFG class of packages F. So that's why I said this morning, I'm fairly confident that you can throw pretty much anything at MapView that comes from the realm of the most popular spatial data representations. All right. Any questions so far? I don't know if it makes sense to ask that, Alex, but if there are, please let me know.
I think those are the ones that that Chris told you earlier to answer, how to solve libpng, and yeah, I think that was already answered.
Okay, cool. All right.
There's a question in the audience. One second.
Yeah.
So the question is why you want to, can you repeat it, sorry?
So yeah, why you want to add the last to start
Are you able to hear that?
Nope, you have to repeat. Sorry.
Okay, so why you're trying to I'm sorry, you know what, I'm just going to carry over the laptop for a second so you can hear the
Okay.
question. Sorry, I'm not an expert on this stuff and I don't want to butcher the question. Here we go. I think that's close enough.
Yeah, so I wonder why you want to migrate from raster to stars. Is that because of the S3, S4 classes, or because of there are more development over stars?
Well, I said this morning, it just makes sense from a data representation point of view, because stars is not limited as raster, or let's start this way, raster is limited to regular grids and 3 dimensions maximum. Stars is not restricted to regular grids. You can also have rectilinear grids or sheared grids or every other type of data that people work with. And so what we can do then is take away that effort from the user to just say, okay, you can throw a sheared grid at mapview, because mapview uses stars internally and can easily convert these into regular grids, because that's the only thing we can show. Otherwise, you would have the user would need to do that outside of the mapview call, but we can do that inside the mapview call. And it just, from a development point of view, makes my life easier, because I only have to develop for one package and not have the same functionality with two different sets of code, one a raster based processing chain and then a stars-based processing chain. So it makes much more sense. I mean, I did this internally already when I started out. Only SP was around and only SP was supported, but then SF came around. And so at some stage I sat down and just basically switched all the SP-based workflow internally to an SF-based workflow. And that has made my life much easier rather than keeping those two separate.
Okay, thank you.
You're welcome. All right. Then earlier I quickly talked about projections.
Sorry,
yeah.
Tim, sorry, there's another question from the audience.
Okay.
Let's see. I can probably maybe have to come. I'm sorry, guys. We didn't really for the fact that we have the online lecture in this room. Here you go.
Yeah, just a short question. We're calling now the mapview function using the lowercase v, but with the show methods, it's using mapview with an uppercase v. So what's the difference? And also there's a difference when you call show methods with the lowercase v.
Yes, I can show that quickly. If you call that with the lowercase v, that just isn't very helpful, right? Because the function mapview, the function definition of map view with the lowercase view is basically just this. And then map view dot dot dot. So that's all that the function definition for the lowercase map view is. That's again one of the design choices that I made early on, and which wasn't really a choice because I didn't think about it too much. I personally like the camel case function naming rather than the snake case with the underscores, partly to do with the German keyboard layout. And so I called it map view with a capital V in the beginning, and did all the coding for the function definitions and the method definitions for the capital V. But at some stage, I and colleagues at the university and some feedback, I think online somewhere, basically pointed me to the fact that it's much easier to write map view just all lowercase. And that's why I just defined a function like this, just for the ease of typing, basically. Internally in mapview, everything is calling map view with a capital V. So there's no magic behind this. This is just a bad design choice that was arbitrarily made at the very beginning by a programmer that was in over his head, let's say it like that. Does that answer the question?
Yeah.
Okay. All right. Shall we continue?
Yeah, I think we're good to continue.
Good. As I quickly touched on the topic of projections or CRS, coordinate reference systems, earlier when I talked about the web Mercator representation of the data that you see when you call MapView. But you're not limited to showing your data or see your data in that one CRS. You can have arbitrary CRS or no CRS at all. So if I create an object that I call brew, where I set the CRS explicitly to NA, then usually MapView should trip over itself because it does not know how to project this data set to the web Mercator representation that we need in order to ensure that things are shown in the correct places. But what MapView then does is basically just show X and Y coordinates as they are defined. In this case, breweries, I think, comes in latitude, longitude, and just skips the background maps because there's no online providers for background maps in latitude and longitude, and we don't know that it is latitude and longitude because the representation of the CRS is NA, okay? But you are still able to zoom around your data, play with your data, and query your data. Nothing changes there. All the, like everything else is pretty much the same. The only thing that's missing is the scale bar because that is only provided for that, or that only works for that web Mercator presentation. Or if you have an arbitrary CRS, like in this case, I'm going to transform the breweries to the, what is it, Lambert azimuthal equal area for Europe representation. Now, now that we have a CRS and you simply call MapView on that object, what happens is that MapView will automatically on the fly reproject this for you to fit on that web Mercator representation of leaflet. So that's pretty much the same as, like that's the standard that happens if you don't tell MapView to do otherwise. You can, however, set native CRS to true, and then the same happens as with the NA case. It will just take the X and Y coordinate representation as is, show it as best it can, and just omit the legend at the scale bar and the background maps. That is quite nice for larger data sets where you need a certain representation to not distort things too much. Okay. The same is true for rasters. So my raster object has UTM zone 25 south. So if I call that, let's just see it, a raster layer. If I call that, then you basically just get an X and Y array view of this without any background. And this is now not a leaflet call anymore, but it's a tailor-made widget that we wrote that is called plain view. That's a library, like a package as well, that's on CRAN, that does not have all the functionality of leaflet. So for example, you don't get these zoom to layer buttons, and you cannot switch the layer on and off and such things, but it has a big opportunity or a big advantage over leaflet that it can handle very large rasters. So you can have millions and millions of pixels, and this one will still be able to show it to you. I'm hoping that I can get rid of this dependency at some stage. We had to come up with this because leaflet does not support showing rasters on a simple leaflet background. There is a CRS that is called simple that we use when for vector data, because there it works, but it doesn't work for raster data. So, but that is work in progress that should be doable at some stage, I hope. But there I'm also depending on downstream developers of JavaScript plugins for leaflet that would then support this stuff. Now, if we do this for a object of class stars, you get an error because there is no support for in plain view for stars layers yet. And I'm kind of hesitant to support it because, as I say, if I can manage to actually be able to show this on a proper leaflet background, then there's no need to have this plain view anymore. But if there is a need and you really want this, let us know on GitHub as an issue feature request, and we can do this. All right, so to recuperate, you have the option of viewing your data with either no CRS definition, any arbitrary CRS definition, or if you have a CRS or a projection assigned to your object and just use mapview, you will always end up with the web Mercator representation as a standard. Now, so far we've just used plain mapview calls without any styling. But that doesn't make sense most of the time. I guess most of the time you will need to at least change the colors or want to change the colors, or even better, map the colors to certain values of the attributes. And that's what we're gonna have a look at next. So there's a color argument, and there's also a col.regions argument. Now, if you ask me why I didn't call it fill rather than col.regions, that is again a historical reason, because at the time SPplot was basically the standard for viewing spatial data, and that is used lattice under the hood, and then just ported the argument names from lattice to spplot. And I did the same for mapview. So I ported most of the argument names as they were defined in spplot, and that's why we end up with col.regions. So basically it's a lattice defined argument name that we just ported over and over. That's just the way it is, and that's just what we need to live with these days. That's not going to change. But the reason I show this and say that I want to fill my regions, so the regions of the polygons, with a white color, is because you might have noticed that usually if I call mapview franconia just like this, you get the white background map as a default, right? But mapview tries to be smart, as I say. So whenever the color representation is too light, mapview automatically switches to the dark background to provide you with some contrast, because if we would plot that on the gray background, you wouldn't see anything, or you'd have to look very hard to figure out there is actually something there, right? So that's why we then switch automatically to the dark representation in order to aid the user in their visual representation. And that just is something that sometimes is not controllable, because you might have mapped your colors to some data of your attributes and might have some really, or a lot of really high values and just only a few very low values. Then the standard color palette that MapView uses or any other color palette that you as a user can provide might just end up having the majority of the data filled or colored in quite light colors. And then it makes sense for MapView to figure out, okay, is it best for the contrast to use the dark or the light background? So I think that makes sense, and I haven't had any complaints so far. Now, more important, I think, rather than coloring all your geometries in the same color, for the intention of what MapView is supposed to aid the user with, is to be able to quickly map data of your attributes to the coloring. And that is done via that zcol argument that again comes from spplot. And what I do now is call the breweries data sets, or these point data sets, and map the coloring of these points to the year that the brewery was founded. And I also changed the layer name, which has implications for the grouping in leaflet and for the legends and here all the layer controls that you get. So if we do this, this is basically what we get. So you get a nice color representation of the data that you see mapped to the foundation year, or the year that the brewery was founded. So in this case, 2007, in this case, in 1885, and in this case, even in 1353. That's one of the reasons why I chose this Franconian data set, because we have a lot of breweries here with a lot of good beer, and I really enjoy drinking beer. So what you also notice is that the labels are now automatically mapped to that zcol as well. So whenever you hover over things, you see what the color represents in plain data, basically. But if you click on it, you still get all the attributes, all the additional attributes that are behind that data point. Now, as we defined the layer name as to be year of, and then BR foundation, we see that we get this layer name everywhere where it's used. So it's used in that zoom to layer button. It's used as a header or title of the legend, and it's also used here in the overlay control. The BR is HTML code, and that just means start in a new line, which is quite nice for the legend, but not that nice for the layer manager, and especially not that nice for the home buttons or the zoom to layer buttons. But that's just something I think we need to live with. I'm sure there would be options to figure all this out, but that is not my highest priority, to be honest. So this is basically just an exercise for you to realize we are working in the browser, so every valid HTML or JavaScript that you supply here, mostly HTML, as a group name in a character string, can or will be then interpreted by the HTML interpreter of the browser, because what you use here, or what we see here, is nothing else than a web browser, basically. In fact, all of RStudio is a big web browser. So with the viewer, you're basically talking about a web browser in a web browser, which sometimes makes things a little bit complicated. Now, if you just call zcol and map it to one of the column names of your data, then you will get a default interpolation of the data from minimum to maximum and just linearly. If whether that makes sense or not is again up for debate, but it seems to work okay. You can, however, customize that or modify that with the add argument. And there you can just define breakpoints for the coloring of the data. So if I now say I want breakpoints at 1300, 2200, or in a sequence from 1300 to 2200 in 200 year steps, then I basically will get a color representation for 1300 to 1500, 1500 to 1700, and so forth. So that allows you to group together your data and represent it in any way you want, basically. You could put the quantiles here in case you have data that is highly skewed, or you can make use of the class int package, define your intervals, and then just pass them via the add argument to mapview, and that will just map the colors to these intervals. Other styling options are obviously legends and labels. So as I said, if you provide a z-call argument, the labels will be mapped to that data, and the legend will automatically be shown in any case with mapview. But if you set legend and label to false, then you don't get any labels or any legends. So it's a very plain, just representation of your data. Now, you might realize if I show you Franconia dollar district, that's just a character vector, right? But nonetheless, mapview knows what to do with it in terms of coloring. So there's basically support for character factor and numeric, and also all numeric representations in mapview. It gets a bit complicated when you get down to the nitty-bitty grids of factors, because you can have levels different than the actual factors, but I think we have this under control as much as possible now. If you want to change the color palettes, you can do it by either creating a function that has pretty much one argument that is either called n or whatever. So it's basically a function that would then allow us to create a certain amount of colors in a certain way. And that's what I recommend. There's this function in base R called color and palette that you basically just pass a few colors. In this case, we pass it 3 colors from the our color brewer palette package. The color palette there is called set1, and then color ramp palette just basically wraps these 3 colors in a function call. If I do this, I now get, if I call colors for length 3, I get exactly those 3 colors back, but I can now call it as, I don't know, 30, and I get 30 interpolated colors between these 3 colors as anchors. So that one should be somewhere in the middle here. I'm not sure where it is, or maybe it's just interpolating. But you get the other one at the end. And so it's basically just interpolating between those colors. And then if you pass this to the call.regions argument, then mapview will color those regions according to your color representation. You can do the same by just hard coding 3 colors, and you can just pass the colors to the call.regions argument as well. So that one then just uses orange, purple, and forest green. Orange for Mittelfranken, purple for Oberfranken, and forest green for Unterfranken, because that is a character vector which is turned into a factor, and these are by default ordered alphabetically. And that's where things get a little bit more complicated, but we won't go into this. If you work with factors a lot, then you might run into some funny behavior there. But let us know. We try to address all these issues so that people can use MapView to the fullest extent, basically. All right, the same applies for colors. You can also use colors, but colors really only make sense for lines, because for point data, if I go to MapView.
Tim, can I interrupt you real quick? We have a raised hand on Zoom.
Sure.
From Gilberto.
Sure, let me just quickly load this, for example. On Zoom Q&A, Gilberto, support stars proxy. Yes, it does. It depends. Well, we come to the stars proxy. So the question is, does the CRUN version support stars proxy? Yes and no. It does to a certain extent at the moment, because it uses a new function to render stars data on the JavaScript side, and there was an implementation that is now obsolete that would, if it is a stars object, just downsample it to the screen resolution, then read it as a stars object, and then render that. But that is now obsolete. Unable to find for signature. Yes, View RGB at the moment does not support stars proxy objects. I hope it does support stars objects, but I'm not sure there either. But I think it does. Not to answer that in a bit more detail. The nice thing about this new method is that we can pass JavaScript functions from outside. So especially for something like View RGB, we could just pass the 3 layers to the JavaScript in the browser, and then have the RGB rendering be done in the browser, which I think is much more performant and better than preparing all that RGB representation in R and then sending that to the browser. It's much, I don't know, it seems to me more native as an approach to let the browser do the calculations, because JavaScript is also quite fast and very powerful. So why is the mapview color function for raster layers not support the col.regions option? Does it not? I think it does. RST is my raster layer, right? So yes, if I go mapview RST and say col.regions is here, it is light. Let's say we have colors, right? So I can just use colors.
Tim, Roberto is also, he had a follow-up question in the Q&A.
Okay. Just to, I'm getting the wrong colors when passing color names to the mapview function. Passing color names for raster data, is that, Gilberto, or is that for vector data? I mean, this is always, it always depends on where exactly that happens. But to answer your previous question, you can use colors also with raster. Maybe you just misspelled col.regions, because if you type it like this, there's no argument matching in mapview, so you're missing an S at the end here. Maybe that's the reason for this one. And then for that one, it's kind of hard without seeing what you're trying to do. So if that issue really persists and we do not clarify this during this tutorial, please open an issue on the GitHub site from mapview, and I'll take it from there, okay? All right, good. So, where was I? All right. Now, so far we've only taken one layer at a time, but most of the time, or many times, you will have more layers that you want to see and maybe want to compare and just put on your map. As I said this morning, mapview has a plus operator, just like ggplot in the end, where you can just concatenate mapview calls together and you will get both layers on the same map. Now, you will get a home button for each of those. In this case, that doesn't make much sense because the B box or the extent is pretty much the same. But you can show and hide these layers individually as you want. You can also, on the right-hand side of the plus, you don't even have to call mapview anymore. If you just want the raw representation of that spatial object, you can just pass that spatial object straight away. So, so mapview breweries plus mapview Franconia is exactly the same as mapview breweries plus just simply Franconia. Okay. So that makes for, I think, rapid construction of maps with different layers or additional layers. You can do this in all sorts of ways. So if you just add your object straight away without wrapping it in a mapview call, you will always get this blue color that is the standard color for mapview. But you can also use mapview plus mapview, and then you can control how that mapview call should look like for each of your layers that you have. And there's no restrictions here. You can add raster data on top of vector data, or actually it's below vector data, but that's just the way it is in leaflet. And whenever you have more than one layer, you get also a zoom full button at the bottom left, because sometimes things are far apart and you want to zoom to one layer and zoom to the other layer, but sometimes you want to zoom out to the full extent of all layers. That's what you can do with this one here. As I said, we also have a list method, which is quite handy for programmatic approaches. You can just pass a list of different spatial objects, and mapview will pretty much do internally nothing else than mapview list entry 1 plus mapview list entry 2 plus mapview list entry 3 and so forth. So if you want to control, but there I say be careful, because this is basically the hill I'm going to die on as a developer, is the list method for mapview. But in theory, you can, with the list method, control all the arguments as well. If so, by passing lists as arguments, so we can match the first list argument always to the first spatial object, and the second one to the second, and so forth. So in this case, we said breweries in Franconia, and we want the legend not for the breweries, but for Franconia. And that's what you see here. There's Franconia, but there's no legend for the breweries. The legend for the trails is there because I simply call trails in the standard way, and that gives us a legend. For the home button, we do the same. We say we want the home button for the breweries, but not for Franconia. So down here we have a button for trails and for breweries, but not for Franconia. So, excuse me, that hopefully works as expected most of the time. Same applies to if you have already assigned your maps to objects, you can just concatenate those objects together, quickly. And it also works for raster data. So if I call the stars object with band 1 and then add the same stars object with band 4, I now get these two layers here, 4 and 1 and 1 and 4, and can just switch between those. So that all just is there for convenience, and rather than setting up two massive leaflet codes, I think this is rather nice to work with. All right, since just the latest CRUN version of mapview, I said this morning, we have a new operator that is basically just the vertical dash or whatever that thing is called, that lets you evaluate two maps next to each other. So what happens then is basically you get M1 on the left side and M2 on the right side. Just to show you, M1 is this, M2 is this. So if you go M1, how shall we call it? I don't know, over M2, you get this, and you can just compare the two maps with this slider in the middle. Everything else works just as before. So if you zoom to your layers, that will work. You can switch the layers on and off. What you cannot do anymore, and that is due to the way this is implemented in a downstream dependency called leaflet extras 2. You cannot switch the background layers anymore. So you cannot have the background maps select from the set of typical background maps that usually ship with MapView, just because this is basically done via overlays. So here on the right side, the base layer is actually assigned on top of the left overlay layer. And internally that doesn't allow, at least at the moment, for having more than one background layer. But that might, I don't know, change in the future as well. You can do this in any sort of way, again, and you can even combine the two. So you can go mapview franconia plus breweries on the left side, and then mapview trails on the right side, and then you will have here Franconia plus the breweries, and on the right side you have only the trails, and you can compare these maps. I mean, with these data sets that come with MapView, it doesn't really make any sense from an analytical point of view to want to compare the points and the lines maybe, but if, for example, you think about the different bands of this Landsat imagery, there it actually makes sense to have the same scene, but the two different band representations that you can compare quite easily that way. So I'm fairly happy with this new operator, and I've heard good feedback so far. So please try it out with your own data and let us know if it works as expected. And this afternoon, I'm going to show you a bit of a more involved example that uses data that is much larger than these toy data sets that ship with the packages. All right, then another nice feature is the burst argument that might come in handy sometimes if you want to dig a little deeper into a certain aspect of your data, or want to quickly just create layers for all the attribute columns that you have. So you want, for each attribute column, you want to have one layer in your map. You can just use the burst argument, set that to true, and then you will get, for each of the columns, in the attribute data or in the attributes, you will get one layer representation here that you can play around with. Okay. You can even do this if you provide in addition a z-call argument, then mapview will not split your whole data set, but like into columns or into layers of different columns. It will then take that one column that you provide in z-call and create different layers from all the distinct entries in that layer. So that can be seen here. So we take the district column and say, burst this column for me, please. Then we basically get these three layers, Mittelfranken, Oberfranken, Unterfranken, with just the behavior as you would expect of everything to happen there. You still get all the pop-ups. So that's just a quick and easy way of creating these layer representations of your data, either split them by rows or split them by columns, depending on what you do. If you provide, like there's a shorthand for that second line here, z-call and burst, you can just provide a column name to the burst argument, and that will do exactly the same as providing z-call and burst. So that fits quite well with the scope of just being able to create quickly and conveniently different types of views for you to analyze. All right, then there's other functions as well. There's especially a view extent function that does exactly what it says. It basically just draws a polygon for you that depicts the extent or the bounding box of the data set that you provide. So that would be the view extent for the breweries. If I now add the breweries there, then you would see that this lines up with the most extreme locations of the breweries. So that's basically comes quite in handy when you have many data sets that are quite large and don't want to wait that long for things to render. You can just see, okay, these are the extents of my data. So, and I'm really interested in the ones that is lying there. So I'm just going to call this one. It also works, as I said, we have a method for bbox, because bbox comes, if you look at the str of that call, it comes with a class. So it's a bbox class. So that's why we can produce a method for it. So it's exactly the same. You can use a map view on the bbox of the breweries, or you can call view extent of the breweries themselves. They produce the exact same thing. And you can also use view extent for raster images. I've noted here there's at the moment no view extent for stars, but that is in the making as well. So and the extent is also then a viable layer that you can switch on and off, right? Just as the raster layer itself. All right. You can change the default base maps that come with mapview, because usually you have all these 5 types here, but there is quite a big variety of base maps that you can use with leaflet. There's a map.types argument where you just pass the names of these providers, and then you get different background maps. For inspiration, you can go to this website that gives you a preview of pretty much all the different providers that Leaflet is able to handle. So there's all sorts of maps here. There's even a fire map, whatever, for the metal heads, if they want to use this, or I don't know, there's many artsy things as well. So I tried to select a usable or like generally usable set of default maps, but you can do this in any way you want here and just use whatever you want there, basically. There's even a hill shading map there that maybe not zoom into England, but zoom into the Alps. So that might be just quite helpful in some cases as a background map. And the way this works is basically you only need to copy this here. We can try this straight away, actually. Let's say map view, which, there we go, map view, KRDM, and then map dot types equals this one, and then we should get that map type as a background, and that actually might make sense for if you work in Switzerland to get the hill shading as a background, right? So it's pretty easy to do this. I mean, it's just so simple because because Leaflet is programmed that way, and MapView is just passing it on to the Leaflet call underneath. So that's easily done. All right, I mentioned this morning that MapView is intended to be a one-liner, and I still fully support that claim. But sometimes you need to customize the settings quite a bit to get to a representation of the data that you are happy with. Now, if you need to, for each of the MapView calls that you make all the time, because MapView is intended for you to be for you to use it often and easily, then it gets a bit frustrating to always have to define these arguments all the time, or you end up copying, pasting a lot of stuff. So that's why MapView comes with options that you can set globally for the duration of your R session. So as long as I don't close my R session, whatever options I set globally will then be used. As a disclaimer, this does at the moment not comprise all function arguments, but only a subset of the most widely used ones. And there's arguments that it wouldn't make sense, like the Z-call argument, for example. You couldn't hard code into a global option to always use founded, because if your data doesn't have a founded column, then that wouldn't make sense. You can see all the options that you can define by just typing MapView options plainly. These are divided into 3 groups: global options, raster data related options, and vector data related options. The global options, you can set the platform. Now, MapView supports 3 different platforms these days. The default is Leaflet, but you also have LeafGL, which we will see this afternoon. And you can, to a certain extent, also use MapDeck. I don't know if you know about that package. That is being developed by a guy called David Cooley, and basically reps DeckGL, which is Uber's open source GIS kind of platform, all browser-based, and can deal with large data. So that can be used as well, but you only get a subset of the MapDeck functionality if you use it through MapView. But if you, I don't know, try to develop something for MapDeck, you can switch MapView to MapDeck and then just use MapView as your workhorse while you're developing, and then you do your final map with MapDeck using their native API, basically. You can set the base maps. So if you don't like the choice that I've made for the default base maps, you can easily change those here. You can set the raster palette mapping function, so the color function for the raster data and for vector data. The verbose at the moment doesn't do much. You can set the NA color, which is at the moment a very transparent light gray, and so forth. For raster data, there's a few things that are, if you have a beefy laptop, you can actually set this raster size to a bit more, but that depends on your RAM and what your browser is able to handle. And then you can also set what we had earlier, the method for the interpolation when we reproject the raster data from bilinear to nearest neighbor if you want to. The raster querying, when you hover with your mouse over the data that you see the raster values, you can also set to click or mouse click, I think it's called. But these are all described in the help page. Map view options. If you go to the help page, you get all the options described here, what it does, and what you can do with them. Okay, I want to show you what this means. So what I do here is I set my base maps globally to be always the dark Kato one and a ocean base map provided by Esri. You can find both of these here, so I know they are valid. Then I'm setting my raster palette to just use the grays. So it's just a grayscale representation. And I'm setting the vector palette to a palette called yellow, green, blue. So it's an interpolation of yellow, green to blue. I'm gonna set the NA color, not to this light gray anymore, but to magenta, because maybe I want to highlight my missing values. And I'm going to set the layers control position to the top right. And also, and this is something that might come in handy sometimes and may be, depending on your choices, you can say that you suppress the viewer and view everything that MapView does in the browser. So you're not rendering your maps in your RStudio viewer anymore like we do here, but every time you call MapView, you will open a browser and get a new tab in that browser. So if I set these options and now call MapView options again, these should be set now. So we have the two base maps. We have magenta as the NA color. We have viewer suppress set to true, and the layers control position is in the top right. So now if I use MapView, the thing opens in my browser. So rather than the viewer, nothing happened here in my viewer, it's still the old map there. Automatically opens in the browser because I set viewer suppress to true. All the points that don't have a founding date associated with them are now colored in magenta. The color palette is the vector color palette that we defined, and our layers control is now positioned up here. And the two base maps that I have is basically that ocean base map from Esri and the CartoDB dark matter. All right, so, and if I do this again for MapView Franconia, z-call equals district, then I again get these options, and they are now set for the rest of the time that I use this R session. So as long as I don't close my R, these options are now set in stone. Same applies to raster data. Remember, we said our raster palette should now be the gray colors, and our NA color is magenta. So we now see the raster data in gray colors. The NA values that you see here on the outside of the layer are in magenta, and we do get the base layers, and this is something, apparently that base layer from Esri is a special base layer that is only defined up to a zoom level of 10. So there's no map data available at any zooms higher than 10. All right, let me just close these again to not overload the browser too much. Then if you want to go back to the default that mapview defines, you can just say call mapview options default equals true. That will then reset the options to the factory settings, and you're back to square one with the standard palette, the light gray color for the missing pixels, and the 5 standard base maps that mapview comes with. So that's quite easy to do. If you want to have this permanently, you can easily put this into your R profile that is located in your home directory. And then whenever you open R, you can automatically set these options to fit your needs, because you might need different background maps for the work that you do. Like, for example, that hillshade. Then you can just put that into the options, set that call in your R profile, and then when you open R, it will automatically use these options globally for that R session. All right. Another option is that FGB option, which is set to false by default. And that's why I set it again to true here. So these things are still things I need to figure out completely. All right, so approaching the end of that first session, I want to show you one more thing that is available in mapview at the moment, but is also still a very young functionality and might not work as expected or hoped in some edge cases. You can use mapview to watch your global environment for spatial data. With spatial data in this context, it does this for, I think, stars objects and SF and SP objects at the moment. I think with raster I have still some problems to get it to work, but these 3 types are supported at the moment. So if I look at my global environment, I do have at least brew and X1 defined as spatial objects. I also have this raster, but as I say, I don't think this is being watched at the moment. So if you call start watching from package mapview, what happens is there will be a background process that basically watches your global environment every second or every half a second. And if something has changed, it will just redraw all the spatial data that you have currently defined onto a map. So if I do that, you see that these things just now come up automatically. Right, we have the stars layer and we have that brew layer here. If I change brew to just be the first one, so if I put that here, so it's basically just the first line of my brew data set. If I just change this and assign it to be this one, then MapView will figure out, okay, something has changed in your global environment and we need to redraw the view. Okay, so now it's just that one point. All the other points are not part of the brew object anymore. You can still use standard MapView calls while the watching is going on, and they will just behave as normal. But as soon as you change something, maybe let me not do breweries again, but Fran equals franconia, then MapView will again check, okay, there's something new on the global environment, and that's the franconia dataset. Okay, now styling is completely limited in this case because it's basically just rendering the geometries. There's no way to tell it just use the whatever column or something and color it by that. However, MapView is again trying to be clever, because if I go here and say I only want to have the one column called district in my object. As soon as MapView encounters an object that only has one column, it will automatically color things by that one column. So if we now go back here, then you get that color representation because MapView sees, okay, there's only one column in there. So I'm going to color the geometries according to that column. So that way you can just work, do your analysis, and not even care about calling MapView anymore, because MapView will just render all that stuff automatically for you. Now, I'm going to revisit that implementation and make it a bit more controllable as to my idea is to have an option that basically says the types that the watcher or the watcher function will watch in your environment. So you could just say, okay, just restrict it to SF data, or just restrict it to stars data. So whenever you do anything else, nothing will happen. But whenever you change something as a stars object or read a new stars object, then it will automatically plot this for you. So there's some exciting times ahead for this. Which in my opinion is again one step further to the standard behavior of classic GIS systems, where this stuff just happens, right? You create a new layer from an analysis step, and that is usually just auto rendered in the viewer once the analysis is done, or once the algorithm is done. So to stop that watching, just call stop watching, and then that whole automatic rendering is over. If I now remove the brew dataset, or say again brew is breweries, nothing changes because it's not watching anymore. All right, with that, I would say it's 1:45. So we have about 15 minutes left, but I would love to actually start the afternoon session here and then do the rest of the large data in the afternoon session. So maybe now's the time for some more Q&A. if there are any questions in the audience, or if not, maybe take the last 15 minutes to play around with your own data, or just enjoy 15 minutes more of lunch break.
Okay.
Alex, what do you think?
Yes, so there is already one question in the audience. It's coming up. Just a second. We're incorporating this now to make it a little bit mobile since people are sitting all day in this event. There you go. Okay, question is coming.
Yeah, one question about the zoom levels. So for some of the base maps, the really close zoom levels are not supported. And when it's zoomed to that level, then it just appears blank. Is there a way to handle it nicer so that it's clear to the user that the level is not available, like not allowed to zoom there, or display the higher zoom levels and something like that?
We have two options here. Let's go to OpenStreetMap because that's just a little bit more contrast. So you're quite right. Usually they go up to either 18 or 19, and then they disappear. Standard leaflet wouldn't let you scroll in any further than zoom level 19 or 18. So you couldn't zoom in anymore. For mapview, I explicitly allow zooms up to, I think, a zoom of 52. Don't ask me why 52. I know there's a reason, but I can't remember right now. Because sometimes you produce these tiny little sliver polygons that you might want to have a look at, and you need to be able to zoom in quite a lot further than like a 10-meter resolution, right? So given that the provider does not say there's no data available here, I can't do much. Actually, I could maybe change the background color from this gray, but then if it's gray or if it's not gray, I mean, then it would be black. You know, it doesn't really make a sense. What we can do is say for the next 2 or 3 zoom levels, just use that one and just make it larger and larger. That is possible, and I might do that in the future just to maybe squeeze 1 or 2 more zoom levels out of this. But I think there's not much more that we can do in terms of alerting the user that there is no base maps available anymore at this zoom level, other than put it into the documentation somewhere, maybe more clearly.
Okay, thanks. Yeah, I remember that in Google Maps, they just used to show this image saying that imagery not available at the zoom level, and now they just don't allow to zoom that much.
Yes, I think I closed this, right? But if we go back to, you mean something like, let's go here. Something like this when I call the Esri base map, map data not yet available. So if I zoom in, but at some stage they do the same, right? They do this at zoom levels 13 and 12 and 11, and then it appears. But if you zoom in further than 14 or whatever, it's the same thing. So that is something that is actually up to the provider to do. But I mean, if that is something you're really interested in, maybe we can do something by just showing a default layer with some sort of images, but then that would blow up the package a bit. But we'll see. I've never thought about it really.
Okay, thanks.
Okay, Tim, there's another question coming from the audience. Just a second.
Nice one.
Lining up.
Hey, Tim. Is there a upper limit of features that you can plot with mapview, or is there reasonable advice you would give?
That's the trickiest question ever, because it's not only the amount of features, it's also how complicated their geometry is. And with that, I mostly mean like how many vertices do you have for the polygons, for example. If you think of a square polygon, it's very easy. You have 4 vertices. Actually, in the representation that we use 5 because it has to be closed. But then you could have one polygon being constituted of or made up of millions of vertices, right? So it's not only the feature count, it's the complexity, and also how are they arranged spatially? Are they completely randomly arranged throughout the feature space, or is there some sort of a spatial pattern in there that goes from east to west or north to south or something? As a ballpark for standard leaflet, you usually hit, let's talk about points, because points are the only feature where feature count equals feature complexity, basically. If you talk about points for leaflet, I would say you can go up to a few tens of thousands of points if you use their canvas rendering rather than the SVG rendering. That is details in the browser, but that basically handles bigger amounts of data still rather smoothly. But as soon as you come to the 100K mark, I would say leaflet just doesn't work anymore, or it's not pleasant to work with it. For things like lines and polygons, that's even less. I would say a few thousand polygons, depending on their complexity, is what you can do with leaflet. MapView, as it does now, not take the standard leaflet road anymore by writing all the data into the actual HTML that you look at, but actually attaching the data as an attachment to the HTML. That frees up some memory for the browser to use to be able to show more. And what I found is that streaming via the FGB option is makes it even more performant. So you can have a few tens of thousands of polygons that way and still have reasonable handling of the map in the browser. But MapView has a solution for this, which is called LeafGL. That's what I'm going to show you this afternoon. And there, if you use that rendering platform, you're basically using WebGL technology in the browser. And that will then allow us to view millions of points or hundreds of thousands of lines or polygons. So as a short answer, yes, there is an upper limit, but it highly depends on the complexity and the structure of your data.
Okay, thank you.
Okay, Tim, I also see there is another Q&A on Zoom
Ah, good one.
by Carl Hendrik X. Canvas
Yes.
rendering, you mean using CSS scripting?
No. In MapView, you have a, where is this? Not just in the options. It should be in the global options. Maybe it's not. Actually, it's not, but you can. That's something that should be in the options. Actually, is it here? No. But you can tell MapView, franconia, for example, and just say canvas equals true in the case of MapView, so that you won't realize this unless you look at the source of the HTML site. This is now using canvas rendering. If you set this to false, then these features are now rendered as SVG features in the browser. As I say, for data sets like this, you won't realize a difference. But the canvas rendering enables you to squeeze out a bit more performance if you have more data. And for leaflet, I think this is something that you provide in the leaflet call. In the options, leaflet options, and there I think you can, yes, there you have a argument prefer canvas. If you set that to true, then you've set up your leaflet map to use the canvas as well. And that's what mapview is doing under the hood if you set canvas to true. Now, if we look at mapview help, I think it should be here, that for SF objects, if I'm not mistaken, mapview has a function internally that is called use canvas. So basically mapview tries to figure out whether the data that is coming in is too large or too complicated to be rendered as standard SVG, and that will then switch the canvas option based on the complexity of the data that is coming in. But as I said, it's not only the amount of features, it's also their complexity in the end. So again, mapview tries to be smart here, but there's no golden bullet, I would say, to say this is the threshold where you need to use this or the other one.